In this unit, we go from lesson 1 to lesson 3. And for this first part, we're going to look at one of the alternative forms of energy for nuclear energy. And for that, we're going to look at nuclear chemistry and nuclear fission. So what will we learn today? We'll learn to understand the basic principles of nuclear chemistry and how to explain the process of nuclear fission. What we're looking at is from an energy source. For nuclear power, it comes from the process of nuclear fission or splitting apart. Elements, or you know them as atoms, they're made up of tiny particles and we call those atoms. Here's one, if you might remember from your chemistry days or the little bit of chemistry you had in biology, the helium atom. Atoms themselves are made up of three kinds of even smaller particles or subatomic particles. We have the protons, the positive charge particles in the center, neutrons, ones with no charge, and then the tiny electrons that orbit these protons and neutrons. Inside the center or nucleus of the atom are again the protons and the neutrons. That's our nucleus, that's our center. And the protons have a positive charge while the neutrons have no charge, just a blank. So that's why the overall center is still positive. And traveling around the nucleus are the electrons. They have a tiny negative charge. The total number of protons and electrons in an atom are always the same. That means the atom is neutral or has no net electrical charge. But atoms also, we have isotopes or forms. For example, the oxygen atom, sometimes these atoms have elements that have a different number of neutrons, making them heavier or lighter versions of their normal selves. In this case, we have one isotopic form that has 8 neutrons for the oxygen atom. It also has a cousin that's 10 neutrons. They're both oxygen, they both have 8 protons, they both have 8 electrons, but this one's just a little bit heavier by 2 neutrons. And we call these forms isotopes. In nuclear fission, we release the energy that's trapped inside this atom. And fission, the word itself, means to split. So when the nucleus of an atom is split, neutrons inside that atom are released. When those are released, they hit atoms nearby. They then split the nuclei of other atoms. And this starts what's called a chain reaction. So it continues over and over again. That produces a lot of energy. A lot of neutrons are now flying out, hitting more and more particles. The energy release is not controlled, but is done all at once. It can produce an explosion like an atomic bomb. It's a lot of energy all at once from these little atoms. The amount of material that you see there for that detonation is about the size of your fist. For nuclear fission, we can release it in a controlled and slow manner, and that way we can use it to make electricity. It heats the water, boils it into steam, and the steam then turns a turbine that generates the electricity. Hence, it's a good form of electrical energy. And that's the